This lesson is going to cover writing polynomials. So example 1 is write a polynomial of least degree with real coefficients and with roots at 2 and -5. So that means that we have 2 and 5 as our solutions. If we recall from the previous lessons, we know that x is equal to 2 and x is equal to -5. But we cannot multiply just the 2 and the 5 and get a polynomial. We need to go back and work in backwards order. So we are going to subtract 2 from both sides, and we get x minus 2, and that's equal to 0. And then we're going to add 5 to both sides, and we get x plus 5 is equal to 0. So now that we have these two, these are going to be our factors. Our factors, in this case, x minus 2, x plus 5. And to find the polynomial, we just need to multiply. So we are going to multiply x times x, and that's going to give us x to the second power. Then we're going to multiply -2 and x, and that gives us -2x. We're going to multiply -2 and 5, and that's going to give us -10. And then we're going to multiply 5 and x, and that's going to give us plus 5x. We're going to combine like terms, so we only have x to the second right there. Then we have -2x and positive 5x gives us 3x, and then we have -10. So that's going to be our answer. We have x to the second power plus 3x minus 10. That is a polynomial of least degree with those roots. For example 2, we actually have an issue because in this case, again, we're going to be looking for the least degree, right? So we're going to be looking for the smallest possible polynomial, but we have a 2 and we also have 3 plus I. From the complex root conjugate theorem, we know that if we have an imaginary number, in this case, this one, then we are also going to get a conjugate. So in this case, we have x is equal to 2. We also have x is equal to 3 plus I. And we also have x is equal to 3 minus I. When you put this in factor form, you're going to get x minus 2. We also have x minus 3 minus I. So in this case, I change the sign to the 3 and the I. That's what we're doing it when we put it to the other side. And then the third one is going to be x minus 3 plus I. So we're going to multiply x times x times -3, and x times I, and we get x squared minus 3x plus xi. Then we're going to multiply -3 times the 3 terms again, and we get -3x plus 9 minus 3i. And then we're going to multiply -i times the 3 of them, and that gives us -i xi plus 3i minus I squared. Remember that we are still multiplying everything afterwards by x minus 2. You're going to start canceling things out. If the i's don't cancel, that means that you did something wrong. So we have xi right here. This is positive, and we have a negative xi. So those two will cancel each other out. We also have a negative 3i and a positive 3i. So those two cancel each other out. Now, we don't have anything else that cancels out, but we still have one I. You have to use your understanding of complex numbers to remember that I to the second power is negative 1. So let's rewrite this when we simplify our information. So we still only have x to the second power. We have negative 3x and negative 3x. That's going to give us negative 6x. We have a 9 just by itself. And we have negative, and remember that you have a negative 1. That's coming from the I square. So this is x minus 2 times x squared minus 6x plus 10. Now we're going to multiply the x times the three terms that we have. So x times x to the second power. So we're going to get x to the third. And we have x times negative 6x, negative 6x to the second, plus 10x minus 2x to the second, plus 12x minus 20. So that's when you multiply everything out. And now you're going to simplify your expression. So you're going to combine like terms. We only have one x to the third power. We have negative 6x to the second and negative 2x to the second. So that's going to be negative 8x to the second. We have 10x and 12x. So that's going to give us 22x. And then we have our negative 20. So that's going to be our answer. When it comes to irrational numbers, we have the same concept. So instead of imaginary numbers, now we have irrational. So in this one, we're going to have three roots. We have x is equal to 4. We also have x is equal to 1 minus square root of 2. And we have x is equal to 1 plus the square root of 2. So when we put it in our factor forms, we have x minus 4. We change the sign. Then we have x minus 1, and we change the sign, so positive square root of 2. Then we have x minus 1 minus square root of 2. And once again, we're going to be multiplying everything out, and we need to make sure that that square root of 2 cancels out. If you end up with a negative, if you end up with a square root, that's wrong. So let's start with x multiplying everything out. Okay, so we get x to the second minus x minus square root of 2x. You can put the x in front. Then we're going to multiply the negative 1. So we have negative x plus 1. And we have positive square root of 2. And the last one, we're multiplying the square root of 2. So we have positive x root 2. Then we have negative root 2. And then we have negative root 2. And again, that's square because it's root 2 times root 2. And we need to remember that we're multiplying the whole thing by x minus 4 as well. So we cancel this one with this one. We cancel this one with this one. And when we simplify, we get x to the second minus 2x plus 1. And the negative square root of 2 to the second power is just going to be negative 2 because the square root is canceled with the square. Simplify again, x minus 4, x squared minus 2x minus 1. And now what we have to do is we're going to distribute everything from our binomial. So when we multiply x, we get x to the third minus 2x to the second minus x minus 4x to the second plus 8x plus 4. And we combine like terms, we get x to the third minus 6x to the second plus 7x plus 4. And that is your answer. In this one, you have irrational answer. You also have a 0 and you have a negative 3. So we know that we have 4 different answers due to the rational root theorem, conjugate theorem. So we have x is equal to 0. We have x is equal to negative 3. X is equal to 2 minus the square root of 3 and 2 plus root 3. So in this one, we're going to have the first factor just x because we know that that's equal to 0. The second factor is x plus 3 because we're changing signs. The next factor is x minus 2 plus the square root of 3. And the fourth factor is x minus 2 minus the square root of 3. Once again, we're only going to focus on the ones with the root 3 to make sure that it's easier. So we're going to do x plus 3. So we deal with those later. And then when we multiply this out, we get x to the second minus 2x minus x square root of 3 negative 2x plus 4 minus 2 square root of 3. Then we have positive x root 3 minus 2 root 3 minus square root of 3 square. You're going to start canceling things out. So anything with a root 3 needs to cancel out. This one cancels with this one. This one cancels with this one. And we know that the the negative root 3 to the second power is going to give you a whole number. So when we multiply this out, we get, when we simplify this, we have x to the second minus 4x plus 4 minus 3. And that's going to simplify to x plus 3, x to the second minus 4x minus, plus 1. I want to multiply the x at the end. So right now I'm only going to focus on multiplying the binomial, the two terms, with the three terms. So the x is going to still be outside. And then when we multiply that out, we get x to the third minus 4x to the second plus x plus 3x to the second minus 12x plus 3. You're going to combine like terms, and you have the x still outside, x to the third minus x to the second, because we have a negative 4 and a positive 3. And then we have minus 11x plus 3. Now, when you have to multiply this x to everything inside, that makes it so much easier. Now we have x to the fourth minus x to the third minus 11x to the second plus 3x.